Chapter 5, Section 3 is about medians and altitudes of triangles. So by the end of this lesson, you should be able to prove properties of medians of a triangle and apply properties of altitudes of a triangle. So we have to talk about three things, and then we'll tie them all together. So the first thing that we need to remember is something called the center of gravity. So every object has a center of gravity, and it's always going to be right in the center of whatever your object is. Now this can change depending on what the shape of the object is, but you've all seen a pop can do this before. You've probably done it on your own. When the pop can's full, the center of gravity is right in the middle. And this line here that's perpendicular to the floor or to the table is allowing this pop can to balance, if we could somehow balance it right here. But right now it's too top heavy. If you tried to balance it here, it would tip over. But after you've drank a little, the center of gravity goes down, and this line ends up being right on top of that little dent right there, allowing you to balance this can. So in addition to center of gravity, you need to know something called point of concurrency. So the point of concurrency is a point at which three or more lines intersect. For what we're going to do today, a point of concurrency is three lines intersecting. Next thing you got to know about is something called the median of a triangle. So this is a segment whose endpoints are a vertex and the midpoint of the opposite side. So we took this segment AB, we found the midpoint at D, and then we connected it to this vertex over here. We could do the same thing for one of the other sides. If you take AC, find its midpoint is going to be somewhere here, and then connect that point over here to the vertex. So now let's put all three of those things together. The point of concurrency of the medians of a triangle is called the centroid of the triangle. The centroid is always inside the triangle, and the centroid can also be called the center of gravity because it's the point where the triangular region will balance. So we did this earlier in the year when we talked about midpoints. We found the midpoint of each of the segments, connected it to the other side, and then you got to balance your triangle on top of a pencil. That point right there is called the centroid. So since we're in geometry, we of course have a theorem to go with this, and it says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So we have this whole distance here, AY. The distance from A to P, right here, is 2/3 of that whole distance. And then this guy right here would be 1/3. And then it's like that for all of the other ones. From C to P is 2/3 of C to X. And that means XP is 1/3 of it. Same thing with B to Z. So let's use that. If I give you this triangle here, we need to identify the relationships between the lengths of all the sides of the diagram. So the first thing you want to check is this the centroid. So remember, by definition, the centroid has to go from the midpoint to the vertex of the opposite side. So if we look here, D is the midpoint, and that's because it's represented by those lines, and it connects to the opposite side. F is the midpoint of AB, again represented by the slashies, and it's connected here. And then E is the midpoint of AC, again represented by this, and it's connected to the opposite side. So because this point G here is the centroid, then we can use the centroid theorem. So if I wanted to find the length of, let's say, C to G, from here to here, I know that's going to be 2/3 of the whole length CF. And if I look at B to G, I know that has to be 2/3 of the whole length B to E. And then the last one, you can kind of tell because it's longer, A to G is going to be 2/3 of the length from A to D. So let's do some actual problems with that. So in this triangle here, DJ equals 30. So from here all the way to here is 30. And then FM is only 12. So what we're going to have to do is find each length. So the first thing I'm going to go through and double check is M, the centroid. I have all of these marks here telling me that those points are the midpoints. So that means it is the centroid. So now I want to find the length of DM. So remember, this whole length here is 30. DM is only 2/3 of that. So we got to find 2/3 of 30, and that is 20. And then they want us to find MJ. So this right here, even though the centroid theorem doesn't tell us, this is 1/3 of 30, and this is 2/3. So you can do 1/3 of 30 and get 10, or you could subtract. If you know the whole length is 30 and you already figured out that's 20, then that side has to be 10. So this next one's a little trickier. The information they tell us is that from F to M is 12. So remember, that's 2/3 of this whole side. So if you were to cut this in half, each third would be 6. So that means this is 6 from here to here. So the first thing we need to find is G all the way to F. So if each one of these are 6, G to F has to be 18. And then G to M has to only be 6. So the next thing we got to talk about are altitudes. So an altitude of a triangle is a perpendicular segment from a vertex to the line on the opposite side. Every triangle has 3 altitudes because it has 3 vertexes. And an altitude can be inside, outside, or on the triangle. So in QRS, the triangle is actually this thing right here. QY is one of the altitudes. That's inside the triangle. But then these other ones are on the outside. And that happens because we have an obtuse triangle. So notice that the lines containing the altitudes are concurrent at point P. Remember, that's when 3 or more lines intersect. This concurrency is called the orthocenter of the triangle. So in an acute triangle, when you draw your altitudes, they're going to be inside your triangle. And your orthocenter will also be inside. A right triangle is a little weird because this is one of your altitudes. It's the right angle. And then this one is also another one. And then this is your last one. So the point of concurrency is down here. Where an obtuse triangle is always going to be something a little weird because you have this one that's on the inside. And then these ones you kind of have to like extend your triangle out. And it ends up always being like this point P that was out here where they all intersect, like this one. So for an acute angle, it's always inside. A right triangle, it's always at the 90-degree angle. And an obtuse triangle is always outside. So let's actually find an orthocenter. So we're going to follow this, and it will help us find the orthocenter of triangle DEF. So point D is at 0, 0. Let's plot that. E is at over 3, up 1, 2, 3, 4, 5, 6. And F is at 1, 2, 3, 4, 0. So here's our triangle. It's an acute triangle, so our orthocenter is going to be somewhere in between. So let's follow step 12. It says find the equation of a line perpendicular to DF. We should label these. Perpendicular to DF through E. So point E is right here. Perpendicular to this, since it's a horizontal line, would be a nice vertical line right here. And since this crosses at x equals 1, 2, 3, that's our equation. X equals 3. And then we have to find the slope of ED, because we need to find something perpendicular to it. So because we have the nice pretty graph here, we can just count I'm going to go up 1, 2, 3, 4, 5, 6 over 1, 2, 3. So 6/3 is the same thing as 2. And then it says find the slope of the line perpendicular to that. So remember, perpendicular lines have opposite reciprocal slopes. So instead of 2 over 1, it's going to be negative 1 over 2. So then we have to find the equation of a line perpendicular to ED through F. So we have this point here, 4, 0. Now remember, we have a slope and a point. So we need to use point-slope form to find an equation. So we have y minus y1 equals m times x minus x1, and then plug stuff in. Y minus the y in my point equals that slope we found times x minus the x in my point. Y minus 0 is just y, and then if we distribute here, we end up with y equals negative 1/2 x plus 2. So let's graph that. I'm going to start up at 2. Negative 1/2 x would be down 1 over 2, down 1 over 2. Goes through there. And then we can see they cross right here. Now we could take the time to find the altitude that's going to go through here, but we know it has to go through those 2 points. So no need to do the math. We just have to find what this point is right here. Now we know that the x value of this has to be 3 because we found it up here. So use that to plug it in this equation and figure out what y is. So we have y equals negative 1/2 times the 3 plus 2. Negative 1/2 times 3 is negative 1.5. And if we add 2, we end up with 1/2, or 0.5. So this point where they cross here is when x equals 3, y equals 1/2. So this point is my orthocenter. We'll do lots of practice with this in class. So you should be able to prove properties of medians of a triangle and apply properties of altitudes. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.